Okay, let's get started. Hey guys, warm welcome to everybody. My name is Deepan. I'm a dev and I work for ThoughtWorks. Today, I'll talk about some of the experiences and the learnings that I've had as a beginner in the space of hardware and electronics. So I've been given around 40 to 45 minutes. I have around 20 slides, so 2 minutes per slide. So let's see how it goes. But if you have any queries or if you have any things to share while I talk, please raise your hands and please make it more interactive if possible. So the first question is how to get started, right? So here is a list I'm showing to you. Not sure if you are able to read through it, but I'll help you. So these are the components which are very commonly used in electronic circuits. To list them a few, you should be able to see the resistors, capacitors of common values, transistors, your MOSFETs, your regulators. You would also definitely need a breadboard, Biro board to start with, jumper wires, and also definitely one should start with a microcontroller. Arduino would be the easiest to start with a very small learning curve. Also, it's good to also get a basic soldering kit. Yeah, that should be good enough to start with. And where do you get all these things? Most of us should be already knowing the answer, which is most of them are available in Registry. So by getting all these things, you'll start getting your hands ready. You'll start prototyping something. So that's how we should begin in this. At least that's how I began in this space, and it really helped me. So yes, the picture is not so clear, but it's a picture of Registry. So a couple of tips if you have not been to this place. One, if possible, take somebody with you who have been there already, because quite a lot of shops and they sell quite a range of products. So easily, it's not so easy to spot the ones that we are looking for. The shops are categorized into different product ranges, and they are in a different location. So it helped me. One of my friends, Deepan here, he took me over there. Two, while starting, it's not necessary to buy very expensive, go for very expensive option when it comes to soldering kit, multimeter. I forgot that. Multimeter will be very useful. We don't have to go for the expensive options. The China-made cheap option should be fine to start with, and once you gather more knowledge in space, you will know how to put get the best for the money you are investing. So save it for a little later for the more expensive ones. Right. So sometime back, around 6 months to 1 year back, a couple of us we started like this. We went to Ritchie Street and got all the components. Did not cost more than 500 rupees. And I came back and was quite excited to build some basic circuits with LEDs, be able to control the LEDs with a push button, without a push button, and all those things, and wanted to showcase it to my family members. And very quickly I realized that I was quite technically challenged in terms of the knowledge I had in the electronic space, in terms of basic knowledge on the concepts, what is current, what is voltage, how do you form the circuit, and those kind of I was not quite aware of all those things. So the next step was I was trying to find out materials in the internet, search for materials in the internet which could help me to overcome that. And found these these options, and I would definitely recommend these for the beginners. It's from a company called SparkFun. The first one, actually, there's two pictures here. The first one on the top is their website. The URL is learn.sparkfun.com. So the reason I like this first material is one, they kind of go at a very correct level of depth. They don't bore you with a lot of details. Uh, and they also cover the topics which are very basic ones. Plus, the second point, they don't expect you to have prior knowledge. Any topic that you take, it will be they will start at the beginning, but they will cover it the right depth. So one of the reasons I think they do it, they have done it very well is the company's main business model is to sell components and prototype boards for hobbyists. Mostly they sell robotic components and prototype boards. So I think they've made the material to suit the hobbyist style of learning, where people don't go through the details. So that's an excellent list of material. The second one, the one that you do see in the bottom, is from the CTO of the same company, named Pete. He runs a YouTube channel called According to Pete, where he does monthly video tutorials explaining very basic popular topics. Again, I got quite a lot of learnings from that. Also, the thing that I really liked about this tutorial set is he gives a lot of insight from a practical application perspective rather than concept. And he shares his experience how he builds things. So quite a good resource. I would definitely recommend these two. So this should not take more than 2 to 3 weeks for anybody to get going and to get more confidence to move to the next stage. So how do you go to the next stage? At least I started by building some basic hacks. There are few examples. I will give you a few examples. One, you can try building a self-balancing robot where a robot balances itself with 2 wheels. That's a very basic hack. And you could also try to build a robotic hand which you can control using Arduino or a RF remote control. Or you can make it to draw something. But the one that I chose is what I'm going to show you the next. It's called a LED cube. So the reason why I chose this was one, it gave me it has a very good visual appeal. I liked it very much. Two, it has the right level of complexity. I felt that it had the right level of complexity in terms of it's not too simple. At the same time, it's not too complicated for a beginner. Also, by doing some research in the internet, I found that most of the materials that I would need to build this are available with registry. So that again gave me some level of confidence. So I thought that I'll definitely build this one. So by this time, I think most of you should have imagined what the problem is and what the solution is. What we are trying to do is we are trying to build a cube with LEDs by soldering the LEDs together. And we are trying to write this should involve a program which controls each of the LED, and it should it should be able to control a LED at any point of time, and by controlling many LEDs at different point of time, it should be able to form a pattern. So that's exactly what is happening. Nothing more than that. Right. So the reason, so I can slightly go into more depth and give you a little more details on what the solution comprises. But the objective of the next few slides and this one is to understand what we will learn by doing one of these basic hacks. So what all we can learn. That's just view that, listen with that objective in mind. So the problem or solution has two challenges. The problem has two challenges to solve. One, you have a lot of LEDs here. To control them independently, you will need a microcontroller which has the number of individual pins that you will need, or control signals you will need to control each of the LEDs. If you consider a 8 cross 8 cross 8 cube, it's 8 into 8 into 8 pins, right? So unfortunately, it over numbers the number of pins that IO pins that any microcontroller will have. That's one problem. We should solve that problem. Two, even if we solve the first problem, the amount of current that we will need to source or sink to get the as many LEDs to glow at the same point of time will be too high. If we don't have proper protection to the microcontroller, it will easily damage the microcontroller. That's the two major problems at least I felt this problem had. Okay, let's go through each of the problem and try to see what the solution would be. For the first problem, where how to control different LEDs. If we try to control all the LEDs using individual pins from microcontroller, then that would be a problem. So let's try to reduce the number of LEDs that we might have to control at any point of time. Okay. So the idea is, if we start with one layer and try to control only the LEDs which are in those layers, which forms the pattern to light up, and the next step, stop it or turn it off, and go to the next layer and do it, and so on. You can do one layer after another, and you can cycle it. And if you do it really fast, you can actually beat the minimum number of frames per second and I can perceive, and you can actually exploit that, and you can create a illumination that the LEDs across the layers are lit up at the same point of time. So that's the key idea behind solving the first problem. So here is a visual representation of how it is solved. If you see all the layers, the cathode nodes of all the LEDs in a layer are wired together. Okay, and similarly each layer will be wired together, and each of the layer will have one lead to control the whole layer. And similarly, anode of all the LEDs in each of the column are soldered together, and you'll have n cross n leads to control each of the column. So totally, for a 8 cross 8 cross LED, 8 cross 8 cross 8 LED, we will have 8 into 8 columns and 8 rows, right? So now, if you have to get this LED glow, what you will have to do is give a signal to this and give a signal to this. And if you have to get all the LEDs in this layer light up, give the signals to all these columns and the layer that you have chosen. So by this we have really reduced the number of LEDs, the pins that you need to control the LEDs, and do it quickly so you create the image. And that's how we have solved the problem also in the previous video that I showed. And even with this solution, if it is a 8 cross 8 cross 8 LED cube, we have 64 columns, right? So we will need 64 plus 8 layers, so 72 pins. Again, we are short of the IO pins in microcontroller. One of the solution could be to either use a shift register or a multiplexer, where a shift register is a IC which has one input pin, and it will have a number of output pins, and each output pin will have a corresponding register. So with the input pin, you can actually write values to the registers, and when you turn on, the output pins will start sending signals corresponding to the values that you had set in the register. So you kind of multiplex one signal to many. So again, so with one single microcontroller, it could use many shift registers, and you could actually get 72 independent signal controls. So that's the solution for the first problem. The second one, not so big problem to solve, but the thing is, here if you look at the circuit, we have 64 LEDs which can get lit up at the same point of time, as many in one layer, right? So the amount of current that you will need to source to get all of them lit up would be pretty much high, which directly if you connect it to the microcontroller will damage the microcontroller. The solution for that is to use components like resistor or MOSFET, which will decouple these two circuits. And it is also a fast switching network, so you will not see the circuit, so you will not see that lag also. So here I am showing you a circuit which I had borrowed from one of the blogs available in the internet. Again, going back, if you look at what all we would try to learn as a part of this solution is definitely we will have a microcontroller. Here it's Arduino. So we will definitely learn basics of writing firmware. Mostly the firmware will be in C. So we will know what a microcontroller is, what a bootloader is, how to interface it, how to flash the program into it, and how do you control, how do you write program to control the I/O pins and send out signals and so on. So that will be one part. Here we see the two shift registers which are connected to it, and here you see the LED grid where each this represents the row and this represents the column. And since we have the row having many LEDs, we decouple the shift register with the LED circuit using a transistor or MOSFET. And definitely we will also learn how to have parallel and serial circuits, how to control, how should we design the capacity of each resistor here so that we don't have a short and so on. So definitely it's a very good hack for a beginner to learn many concepts. And actually I tried building one, and I also built one. I'll show you the demo. It's a 4x4 x4 LED cube, but the circuit is generic enough to support even a bigger LED cube. So definitely after building this, it gave me quite a lot of confidence that I could make real progress, because if you look at the state I was starting with, I did not even know how to get one LED lit up. So starting with these kind of basic hacks will really give you confidence. At the same time, it will not be going forever. You could do it within 1 month or so. And not to leave out, you will, at least I enjoyed soldering the LEDs together a lot, and I learned a lot, gave me a lot of confidence on that part as well. So the LEDs have to be soldered, and you do it repeatedly, one after another, so you get a good experience. So I'm going to turn this off. So having now we have reached to a stage where we have a decent confidence of what the space is and what confidence that we have built a basic product. The next step, at least in my case, was to have a goal of building something really big. And at least for me, it was like I had to build I wanted to build a quadcopter from scratch. I think the next talk will demo if somebody has already done, but I'm in process of that. I'm not reached the goal, but I'm working towards it. When you have such a bigger goal where you work towards a bigger problem to solve, definitely you will very soon realize that the components that you will use to build the solution will be little more sophisticated, might need more efficiency. So I have to have a lot of skills before I can actually do something like that. So I'll quickly give you an idea of what all it takes to go there. One, the first prerequisite is to have access to the components that you need. When it comes to more sophisticated microcontrollers or sensors or ICs, definitely they are not easily available in India or at least in Chennai. Very soon you will realize that 9 out of 10 times whatever you're looking for is not available in registry. So what are the sources? Just before I go to the next slide, I'll also explain what these are. This is a prototype board for Nordic RF module, which is there's a RF chip here. I don't think it's clearly visible. This is a sensor board. Triple axis sensor board with accelerometer gyro and so on. And this is a discovery board, which is more like a prototyping board for ARM-based ST microcontroller from ST Electronics. So this is my experience in terms of getting access to the components. I'll go the three groups here. I'll go one by one. First one, eBay.com and AliExpress. eBay.com. So you see eBay.in is separate here. So the thing about these two providers, pretty much similar. Very cheap, not so great in quality. Mostly the components are shipped from China or Hong Kong. But most of so not so great in quality compared to the other providers, but it's okay to start prototyping. Good thing about is you can order individual items. You don't have to order in bulk because the shipping, they don't charge much if you for shipping, even if you ship it. 3 out of 10 times or 15 times I have lost my products. But since they are of not too expensive, since they were not too expensive, did not bother me much. Most of the prototype boards, for example, the previous ones that I showed, right? This one would cost around not more than 1,000 rupees. Yeah, so and if you compare between these two, eBay.com and AliExpress, I felt that AliExpress suppliers, most of the time I've seen that they provide you a tracking ID where you can have an international, that's a site, China mail site, where you can go and give your number and it will list where the product is. But please don't expect it to work like the domestic courier service. They update it once in 10 days or 14 days. And most of the time, actually, the shipment get lost. They lose track of the shipment. Eventually, the product reaches you, but they would lose track of it. Also, even if the product is lost, I don't think it's worthy to go and climb that. On that front, eBay is little slightly. I felt that eBay are little suppliers are little more friendly, wherein they were more ready to ship a new product without extra charge, but which did not happen in AliExpress. So that's the rough thing. At least these days, I'm not going for this option just because of the time it takes. You lose interest if it is 2 months. If you are going to get after 2 months. Also, one more thing, it's good to give an address where your local postman can find. At least my home definitely, even the courier doesn't reach me. So I gave most of the time I gave Corporate office address and I got most of the time. So the second group is these providers like Mouser, DigiKey, Elements. I've not tried these two, but mostly come up in the same category. Mouser I have tried. It's a US company, and 10 out of 10 times you'll find what you are looking for. So they have a huge catalog, and they have almost they will have all you are looking for. Two, they are also not expensive. They are very cost effective. But the real problem with this is two. One, you'll have to go for a bulk order because they don't do India Post kind of shipping. I think they will use FedEx, where they will charge around 2,000 to 4,000 rupees for every shipment. So, but the best option would be to, if you have somebody to travel, if they can bring the parcel to you, that will be the best. I got one like that. The only thing is you have to have the complete bill of material with you. Doesn't work for a single prototype board orders, like having single boards or components. The third category is the Indian providers called there are companies like ComKey, eBay.in, Kits and Spares. There are two categories here itself. ComKey, I found this website, Bangalore-based company. I've made some purchases from them. They have most of the common surface mount components. When I say surface mount, they are very small chips, a little more rare than the normal ICs that you get in DG they have a good catalog of it, and they ship it very quickly, like 1 or 2 days. I was quite happy with them, but 5 out of 10 times you will find what you are looking for. You shouldn't expect more than that. Kits and Spares is again, I've tried this. What they are doing is an interesting thing. So I think Element 14 website, they don't sell it, they don't do B2C, they do B2B. So they expect a TIN, a proper tax code number for you to sell anything to you. So these guys, they aggregate orders to this website, and they purchase and send you back. It's more reliable compared to that group. At the same time, they don't incur a lot of shipment charge because they aggregate a lot of orders together. But you will have the same problem of you will have to wait for 1 month. I ordered twice. Both the times it took 1 month for the item to reach. And this was interesting. RS delivers. So they have a India website where you can actually order components where they ship from other countries, warehouses from other countries like UK and Hong Kong. And they claim that the shipment is free, and they did not charge any extra fee. I made one order with them. The item reached within 2 weeks, and they have a cash on delivery option as well, so pretty good on that. But I'm not sure about the price, if they are including the charge in the component price itself, but definitely worth trying. So this is the rough sources that we actually have, and if you look at it, at least I've many times felt that there's a good opportunity on this problem to solve, which I'm not very much interested, but definitely. With a growing interest in the space of IoT and so on. So that's the first prerequisite, where to get the components and prototype boards from. The next one, at least to my opinion, was the firmware. Any solution will include a firmware. So how does a microcontroller, when it comes to a firmware, mostly you will have a microcontroller, and what language do I write my programs in, and what all I have to do to to program a circuit. So this will give you a very rough idea of what the space is like. Generally, you will have an IDE like the software field. Eclipse is a IDE which is popularly used in the open source space. You write the program in C program, but with a lot of frameworks and libraries which can support the corresponding instruction sets supported by the architecture of microcontroller you choose. So you write the program here. You'll use, well, I'm describing the open source solution here. We'll see the other option also, but now the focus is on open source. GCC, open source GNU has GCC tool chain, open source tool chain, where you will find all the compiler, interpreter, linker, and all those things, which can take your program and convert it into a machine code. And mostly, at least in this space, I've seen that the popular format that is an output of this is a hex file, which is more like a hexadecimal representation of the binary, but with a little more semantics to it. So it is a little more human readable. So that's the output of this. Let's skip this guy for now. Once you have this hex file, you generally would use a programmer. You will feed the hex file into it, and mostly this will be your computer, laptop, wherein you will connect using USB, and the hex file will be flown into the programmer, and this programmer will interface with the actual chip IC. Here I've got a picture of prototype board, but it could be an individual IC with minimal circuits built with clock signals and other power and whatever there is necessary for an individual IC. And mostly this interface between this guy and the IC will be through SPI, standard serial protocols. would flash the binary or the program into the IC. So that's how the whole thing works. And what is this Open OCD? Open OCD stands for Open On-Chip Debugger. It's nothing more than a debugger that you use in the IDE. And the really cool thing about this, it can break on the program that executes in the chip. So that's really cool. So you can debug what's happening in the IC microcontroller. Right. And here is a rough idea of the space itself. So as we saw in the previous slide, you have this is the ARM toolchain. This is specific to ARM, but it could be any open source toolchain. You have OpenOCD and Eclipse. Here you have quite a lot of players. Quite a lot of them commercial, most of them. So they will charge you for the IDE and they provide the complete toolchain for you to work on. And interestingly, I found that the electronics or hardware space, when I say electronics, it includes the firmware, is not as rich in the open source materials as that of the software. Even the companies like STI Microelectronics and so on, they kind of officially support these tool chains more than that. So even if you look at their guide, user guide, then you'll see that they will have proper steps for this and not that. That will be like one or two people who would have tried that and solved that and written a blog. That's again a good opportunity in the space, and I think that's one of the reasons right now the space is it has a big barrier in terms of people entering it because of all these things. Not only because of the skills that you have to acquire and a little more than the accessories that you should have, not just the laptop but many of them, but also this very little open source contribution in this space. So that should give you a high-level idea of writing a firmware, and also a couple of days back I saw this interesting answer somebody has written on a question of what are the different kinds of microcontrollers that are available in the space and what I should learn if I have them. So mainly there are four ARM ARM based. Most of cell phones has ARM based ICs microcontrollers. We have AVR, 8051 based and PIC based. I've not worked on the PIC, definitely, not much idea, but I like the answer. He says that you go for ARM based microcontroller when you are trying to build a very highly sophisticated solution, where you are very concerned about the efficiency. You need a lot of analog to digital converters or digital to analog converters, where you work on both RF, analog, digital, all three. So those kind of sophisticated solutions will go for this. AVR is the next bigger category. The really good thing about it is the community it has. It's quite popular in the in the college kind of projects, but also a lot of people for a very long time they have worked in this. So you will find better support for AVR chips. For example, your Arduino comes with Arduino comes with Atmega chip, which is from AVR. And 8051 is very not so sophisticated as the other two. One example is I showed you a Nordic RF module in the previous slides. So that uses 8051. I remember reading it in the user guide. So that uses 8051 based microcontroller within itself to manage the queues, and when it has to interface through USB to the laptop, it uses 8051 based microcontroller architecture to define the queues and implement that part. So I think it will be like a very simple solutions will follow, and this is more like looks like outdated. It says that used in refrigerator, low budget projects, and low community support. So that will give you the a rough idea of this one. Mostly we'll go with AVR or ARM based on the problem that we are trying to solve. Okay, I'll come back to that slide, but okay. Okay. All right. So quickly start. Okay. Then let's get. Okay. So the next challenge, that is the next skill was if you have based on the solution. This may depend on the solution also. If the solution needs surface mount components which are very small in size and very complicated to work like this, if you can see relative size here. These are good in terms of if you are trying to build a quadcopter. You might want to have very small boards with small components, so they give out very less heat and they are more efficient also. They occupy small less space. They are more efficient in the space of RF and so on. Based on the solution, we might have to work on surface mount components. And definitely one advice is go for a very high-end soldering iron, preferably with a digital or not digital temperature control, where you would have better control of the temperature. And again, you would also have chips like this where you don't have the pins stretching out. So here you might have to use a reflow process where you have to apply LED, and you have to heat the whole area so that it melts and it gets soldered. And you get prototype. I've got some prototype boards like this from eBay.com, and I have at least the way I started was practicing soldering those kind of chips. You definitely need some lenses. This is like 20. Sorry, this is like 2x lens, where 2 to 3x lens, where it will magnify the image and can be used during soldering. And this for inception. To inspect the circuit after you solder. So this is like 20x magnified. And here is a quick demo of the outcome. So I'll quickly explain what it is. I don't think you can see. So here is a minimal circuit, and here is the prototype board. You will find a very small IC here. Definitely I'll share the link of the PPT so you can have a look. This solves the board various surface mount components soldered to it, and a minimal circuit built on it, and the Arduino just powers the whole circuit, and you see the build the blink program in action. Moving on, at least the last key skill that I thought, at least to my opinion, is important for hobbyists and people who try to prototype, is creating PCB boards. The space is like you have vendors available where you can make an online order. You can give the image and they could make a PCB and they will give it to you. But they are quite, it works only for professional end product when you want to manufacture them. But to prototype, at least I felt the time they take to deliver it and the cost involved might be a little higher, especially the time more than the cost. Being able to prototype or fabricate a PCB at home is another important skill and not so complicated skill. So the process is like this. You have special papers available, which are like polished paper. You can also use magazine. I bought this from eBay.in and they are available, and eBay.com has a lot of them. You print the circuit into it in a mirrored fashion. Then I got a copper clad, cleaned it very well using Vim lemon viscous liquid. That is good enough. And use some acetone definitely to remove all the oily surface. And you shouldn't even touch the thin clad after doing all this process, because what we are trying to do is to transfer this circuit into this. So it should be quite clean and smooth. Then you apply some heat using iron box. People also use laminators to get some heat. And you place it correctly and then apply a lot of pressure, like 4-5 minutes. If you're lucky, if you soak the whole product into the water for like 5-10 minutes and peel off, the whole circuit should be transferred. At least this comes in practice to know standard, but you try and definitely within a day's time you will understand what you have to do with the components available. You can have this. The next step is I think we should go here. Have ferric chloride. This is again available in eBay.in, 100 rupees. You dip the chip into, the PCB into it, 10 minutes. So this will be available as a powder. Mix some water, dip this, and this should automatically take away all the copper around the circuit which the ink doesn't protect. And you clean it, you'll get the final product like this. Very interesting learning that I've had during this process. One, there's no easy undo option like software. For example, I'll give you the learning that I've had. I went through all the pain of this one to this one, this one, and this one, right? And I was quite excited, and I tried soldering the IC into it, this guy, and I realized that the IC was a little bigger. So then I understood that the zoom level of the printout was mistake. There was a mistake in the zoom level. So everything was thrown away. And again, okay, next week, I generally do this in the weekend. So next week, I try all these things. Again, came here and found, okay, I did not mirror the image before taking a printout. Very costly learning because I wanted to test the whole process. I borrowed this circuit from one of the blogs. They used a miller to actually mill the parts away, so they didn't have to mirror it. So I had to transfer it to this guy so it will get mirrored. So again, after reaching it, I was rotating, it's not fitting. So then I felt that okay, I forgot to mirror. So again, another interesting learning. Then I was quite excited. Third time I got the chip done. I was quite excited and started soldering and realized that the board was like this. After I have soldered with a lot of pain, the very small one, I felt that I did not file the edges. So this will not fit into the PCB slot. Sorry, USB slot. So again, I had to cover all with small papers and some cloths this area to file it using a file. Then by the time I finished that, the chip came off. Again, I had to solve it. So this is the final product after soldering, and this is a USB, a serial to USB converter. So you give serial connection to USB. You can use it to debug. And this is a demo which I'm not going to show. I have this product with me over here. Maybe during the break, if you are interested, have a look. If you want to. So yes, so I'd like to end the talk with that. So at least what the message I would like to convey is, I'm in the stage, so I'm working towards solving more problems to build a quadcouple from scratch. But at least the message I would like to share is, it was not like 2-3 years back. There are a lot of interest towards this space of IoT and hardware. So there are a lot of open source materials available, which is making it possible for a beginner like me to get into the space. So the barrier is coming down and down. So definitely like to share any information if you want, you can contact me. And wish you should also try it, and wish you good luck on that. Thanks. I can take any couple of questions. Then.
Is there a community or a set of people you could go for guidance or something like that? Like active support community for you to go and talk about your problems and get.
Yeah, at least I've been seeing that the past 2-3 days I've seen a lot of community, a lot of meetings like this, events like this happening in Chennai. One happened yesterday. Today it happens here. Mostly we are targeting towards this space here. And again, I think there's one the next week, the next month. It's from the Makers Club in Chennai. So it looks like the community is building. Not like you have everything ready made and you can go and use it. Definitely not like the software suite. But I've seen, looking at just the invites and the event links, definitely looks like it's going a lot.
When you had a problem, I mean, apart from you Googling, is there anything which you used to help yourself? Like
No, mostly it is this one. And when I generally build something, I look for the circuit in the internet and try to understand it. So most of the time I don't understand. So generally what I would do is I'll go to there are certain providers, like if it is an ARC-based chip, the Nordic company has a forum where it has a community, decent community. I go and post that, and I've seen that I've always had some replies. Though they are not like straightforward solutions given in the space of software, mostly they try to get me to a better state. So, but still you have to go and probe after a lot of googling, and the time it consumes to solve each and everything, if you want to properly understand and implement, is very. And I think that barrier is making people to also not progress or go off the space. All right, I'll close with this. I think I've taken more time than you wanted. Sorry for that. Thanks.